out, we will check it. So is it 4b upon a into a plus b into cos this, or it is 4a plus b, 4b into a plus b into, divided by a into cos this. So that we have to check. So this is like this oblique sign is given, but this division sign is for a cos of this whole, that we will check when answer comes out. This we have to prove here. So length is this, okay, that we have to prove from these two curves. The same thing, we have to find out what is the length of the arc of the curve given here, which is given by s equal to under root of, okay, limit whatever integration is there. Your limit says something, I think, where s being measured from the point at which theta equal to 0, where theta is pi b upon 2, pi b upon a. This is the initial limit, I think. The s being measured, this s arc, length of the arc, being measured from the point at which theta equals to, from measured from, this means this is the initial point. So 2, let me take theta. From this point, this is from initial point. From theta equal to this 2, theta equal to theta. This is the initial point. It says s being measured from the point at which theta equal to this. It means from the point to this is initial point. So limits are now here from theta equal to pi into b upon a to theta equal to, let me take theta. Next point is, so let me check. So this we have to prove here, that s length of the arc is this. The length of the arc, this we will check later. Let me now rub these 2 points. So this I just wanted to note down here so that one can understand that what we have to prove here from these 2 points. Now the solution, answer, when answer comes out, then I will check it from what is the answer given here. Okay, let me now find the solution. Solution here. So what is the s? So we know that s is s equal to here 0 to theta. Theta equal to what is pi. Theta is pi b upon a. Pi b upon a here to theta. That theta equal to theta there. And this is under the square root. This we know about dx upon d theta. Here it is d theta, all right, plus d by d theta whole square, whole d theta. This is the formula which we have to apply. Okay, this is equation number, let me take third one. This is the first and this is the second one. So differentiating first and second, differentiating first and the second with respect to theta. What do we get here? Let me check. So dx d theta will give us a plus b is constant. Let me write here, this is minus sine, for differentiation of cos is minus sine theta. This is minus of a plus b constant, as it is sine theta, cos theta differentiation is minus sine theta. Minus sine, this is minus sine here. But cos theta is differentiated as, okay, but here cos theta angle is having a plus b upon b is a coefficient of this. So that will also come out. This will be b into, let me write the angle first, a plus b upon b. Why this? Because angle which is coefficient a plus b upon b into theta will also be differentiated again, and it is cos theta is sine theta, sine of a plus b upon b into theta. Let me write like this. Have you got this point? This is theta, coefficient of theta is a plus b upon b, which is again differentiated by function of a function method. It will give us a plus b upon b. B cancelled out now. It is a plus b into sine a plus b upon b into theta. Now let me again revive this. Complete. Okay, it's complete. Now let me further write it down properly. So this is minus a plus b into sine theta, plus this is a plus b now left over into sine of a plus b upon b into theta. Okay, so this is, let me take equation number fourth, yeah, which is fourth one. Let me change the marker. Okay, now let me differentiate. Here a plus b is also common, but that let me write down as it is. And then divide, and divide the theta is equal to what? Here it is. It is a plus b constant as it is. Sin theta differential is cos theta. Then this minus sign. This is minus again b into a plus b upon b, because coefficient of angle theta into a plus b upon b is again multiplied, and sin theta is differentiated as cos theta, positive. Cos of angle a plus b upon b into theta as it is. Same thing. Or we could write here like this. This is like theta and this angle. So angle of cos and sine both are a plus b upon b into theta. A plus b upon b into theta. Same. Okay, so this b and b cancel out. Let me write it again. It will give us a plus b. If I take a plus b common, it will give us cos theta minus okay, a plus b common, so it is cos of angle a plus b upon b into theta. These two steps will be obtained. Same value is here, a plus b is common, but this is negative sign. This will come out first. Now let me square them and add them. So applying, putting those values here. I'm sorry. These are rubbed. I'm sorry. This is minus sine a plus b into sine theta. It was here. This was value of dx d theta. Fourth equation. This is the fifth one. Okay, this fifth equation. This is the fourth one. Fourth equation is value of dx d theta, and fifth equation is having value of d by d theta. This is this value. Okay, now let me substitute them here. It will give us, here theta was pi into b upon a. Pi b upon a. Okay, the limits were there. Now again let me write theta equal to pi into b upon a to theta. Upper limit we have taken as theta because it says from this point to that point. Okay, so from that means initial point is this theta equal to pi b upon a. That should be understood. Now let me write the under the square root. What do we get? So a plus b, which is will be whole square, because whole square, and so a plus b will come out. Let me take outside. A plus b is out of the square root because whole square of that will be common to all the four steps. These two steps here, a plus b common, and a plus b here also common. So a plus b I have taken outside, out of this square root. Now let me write here. So first point is sine. This is sine of a plus b upon b into theta, which is positive value. This is value of dx d theta whole square. Okay, so and minus sine, this is sine theta whole square, plus sine, second point, it is cos theta minus cos of angle is again a plus b upon b into theta. Okay, so this value is also whole square into, complete this into d theta. This is what we have obtained. Now let me open this hole. It will give us, let me square this hole. So those two equations we have applied here, we have used here, they are removed now. Now let me clearly write it down. Now this limit, before limit I have taken a plus b out of this sign of integration. Here theta equal to pi b upon a to theta. Now under the square root, let me check what comes out to be. Whole square of this plus whole square of this, it will be sine square a plus b upon b into theta plus, let me write sine square theta, the sine square theta, minus sine, it will be twice sine theta into sine of a plus b upon b into theta. Second step is plus cos square theta plus cos square, this is a plus b upon b into theta, minus sine twice, sorry, it is also minus sine, right? Minus sine twice into cos theta into cos of a plus b upon b into theta. Okay, so this is whole under the square root value, and this whole is d theta. Now, what do we see here? This value sine square a plus b upon theta and cos square a plus b upon theta is 1. Why? Because angle are the same. Sine square theta plus cos square theta is equal to 1. That we know. Similarly, this sine square theta plus cos square theta is also 1. 1 plus 1 is 2. So let me write that value here. Okay. So this is finally obtained as a plus b. We are solving it. This is theta equal to pi b upon a to theta. Okay, and this is under the square root. Now this value sine square theta plus cos square, this angle is having 1 plus 1. Why? Because sine square theta plus cos square theta, since, let me write here, sine square a plus b upon theta into theta plus cos square a plus b, same angle, sorry, this is b here, upon b into theta is equal to 1. Similarly, sine square theta plus cos square theta is also 1. By trigonometric formula we know about this. So these two values are same, 1, 1. This is 1, and this is 1, and this is 1. So this is 2 here, plus 2. And minus 2 if I take common out of these two values, minus sign are taken common. So that will give us, let me write first cos value, it is cos of angle a plus b upon b into theta into cos of theta plus sine, the sine of a plus b upon b into theta into sine of theta. These two values, because this is twice of sine theta, sine a plus b into theta, which is here sine a plus b into upon b into theta into sine theta, and this is twice minus sine minus twice cos theta cos a plus b upon b into theta. These two values are same. So 2 we have taken common, minus 2, and this is 1 plus 1 because these are the square values. So 2, the value has come out. Let me write it again. So what it gives us? Okay, so it gives us a plus b. If I take 2 common out of this is twice 2 minus 2, so this 2 common, this under root 2 will come out. Okay, this is pi b upon a to theta angle. Under the square root it is now 1 minus cos of this. This is what cos a cos b plus sin a sin b. It is cos a minus b. What the point? If I take theta common, that will be cos of, let me write here, cos of a plus b upon b minus 1 into theta. So we could write here theta minus theta. Let me write theta, and this is also minus theta. No problem. This is cos a minus b, because cos a cos b plus sin a sin b. We know that cos a cos b plus sin a sin b, since this value is equal to cos of a minus b. Try to understand. If there is plus sign, then it is cos a minus b. If there is a minus sign, then it is cos a plus b. That is the point. Okay, so this value will give us cos a minus b. this a, we have taken this a plus b upon b into theta, that is a minus b. So this is value into d theta. Let me write into d theta here. So what do we get? Let me write further. Now this is singular angular. Let me take what it comes out to, under root 2 into a plus b. This is out pi b upon a to theta under the square root. So this is 1 minus cos of what it comes out to be. It is a plus b minus b upon b into theta. Minus b cancelled out. It is a upon b theta, or a by b into theta. This angle is there, into whole d theta. This is 1 minus cos theta. We know about. What is that? That is equal to 2 sine square theta by 2. Whatever this angle is, that upon 2. Upon 2. Okay? It is 2 sine square theta by 2. So whatever this angle is, this is single angle, suppose AB into theta. So that upon 2. So twice B will come in the denominator. So A theta upon twice B, the angle will be. It will come out as under root 2 into A plus B. Okay, this is pi B upon A to theta. It will come out as twice sine square, whatever this angle is. This is A upon A theta upon B it was, so it is twice B. Half of that angle, whatever this angle is. 1 minus, we know that. Let me write this formula. What is the formula here? Since 1 minus cos 2 theta is equal to 2 sine square theta. Okay, or cos 2 theta equal to this cos theta equal to 1 minus 2 sine theta, or 2 sine theta equal to 1 minus cos 2 theta. Now, if this angle is 1 minus cos theta, it will be 2 sine square theta by 2. This is the formula here we have applied. 1 minus cos theta, whatever angle is, this is a theta upon b, a theta upon b angle is, so this is a theta upon twice b, half of that angle. Okay, now this is square and square root on sine cancelled out. This is d theta here, out of this bracket. Okay, so now let me further solve it. So S is giving us what? Under root 2 between bracket, it is a plus b. Okay, now it comes out to be pi b upon a into theta, up to theta. Under root 2 has again come out. So this is 2 here, 2 will come out, and it is sine only. Now square root and that cancel out, a theta upon twice b now into d theta. This is to be integrated now. Okay, so that is the value which we have to now integrate, and then we will get the answer. Now let me check what is the answer here. Okay, so this under root 2 is twice of a plus b. It's twice of a plus b now. Square root 2 into square root 2 is 2, a plus b. Okay, now integration of this value will be what? Sin theta is minus cos theta. It will be minus cos of a theta upon twice b. Now we have to divide by a upon twice b. Why? Coefficient of theta angle is a upon twice b, divided by the coefficient a plus b. Now limits here is pi b upon a to theta. The limits here, this twice b upon a. Twice b upon a means 4b upon a. This a will come out here, and twice b into a plus b. This a plus b is also there. So this is with negative sign, minus cos a theta upon twice b. Let me put the limits here. This is pi b upon a into theta. Okay, so it will give us 4b upon a into a plus b. 4b into a plus b here upon a plus b. It means this is 4b upon a plus b upon a. That is good. Into this must be cos. Let me take what it comes out to be. Now this is minus sign here. If I put the upper limit, it is theta only. It will be minus cos of a theta upon twice b only. Minus was plus, then this plus sign. And when we put the lower limit, it will be cos of, now it is pi b upon a. It is a into pi b, this is twice b. Sorry, pi into b upon a. A cancelled out. B cancelled out. Is pi by 2 here. Pi upon 2, pi by 2. Cos pi by 2, 0. That is 0 value. That gives us 4b upon a into a plus b into it is cos of a theta upon twice b. It is negative, but it is magnitude we have to take. Length of anything is positive, so we have to take its magnitude here. This is the value. This is 0 plus 0. But cos pi by 2 is 0, as cos pi by 2 is 0. This is pi by 2 only. A is cancelled out, b cancelled out, pi upon 2. Cos pi by 2 is 0. Cos 90 is 0. Since this value is there. Therefore, this value comes out to be negative, but we take positive. My magnitude of length is, we have to take the magnitude of the length. Length of the magnitude is equal to 4b into a plus b upon a here into cos of a theta upon b. A theta upon twice b. The twice b here. So this is the final answer, positive. Magnitude we missing. This is magnitude of the length, which is positive. This is positive here. Okay, this is the answer of the question, which we had to prove that s equal to 4b a plus b upon a into cos of a theta upon twice b. A theta upon twice b. This is a theta upon twice b, angle of cos. Okay, so this is here a is upon this angle, or let me write here, this is into, but this is upon a. So this is the answer here. 4b upon a into a plus b into cos of a theta upon twice b. Hence proved. This arc, length of the arc is the same we have obtained here. Okay, so this is the length of the arc of question number 11 here. This is done. So now this lecture over. Now in the next lecture series I'll talk about polar equations. Okay, rectification by polar equations or of polar equations. Okay, that will be discussed in the next lecture series. But in this lecture series, it is obvious that what is the formula. Mostly one formula is there. But in case of polar equations, we use two formulae that we will discuss about. Those two formulas we'll discuss about. And in case of Cartesian equations, also we discuss about two formulae. Okay, in case of x and y, so that by the discussion. So this is today's discussion. All 11 questions are clarified. Here. So these clarification of questions of this parametric equation series will give us a lot of insight in the topic. Okay, then see you in the next lecture series, which is also very important one. See you then. Okay, see you.